Alright, this is part 2 of section 3.5. So what we would have is g of x is equal to f of x plus 1. And this would be your final answer. Okay, if we look at this transformation of y equals 1 over x, and again, we don't really need that because within our toolkit function, we should know the shape of that. So write a correct equation for this transformation. Okay, well, if we look at the original one, let me go back to the toolkit function. Notice how it has an asymptote at the y-axis. Now back to ours, right here. Notice how it has an asymptote at 4. Okay, so it moved from being over here to the right 4 units. Okay, so what we would have would be 1 over x and then something 4. Since it went to the right, this is going to be a negative. So the original function is the black function right here, so that is 1 over x. Now the blue function is 1 over x minus 4. So notice how it shifted to the right by 4 units. Write a transformation for x squared. And x squared, we know the original function starts at 0 and does this right here, makes a U shape. But notice we have shifted to the left 1, 2, 3, 4, 5 units. Okay, so what our formula will be is this whole thing squared, and then x, and then something 5. Since we went to the left, this is going to be x plus 5. Black function is the original x squared. Notice how it starts at 0 and goes up. And the blue function is x plus 5, the whole thing squared. And notice how it has moved to the left 5 units. Talk about reflecting about the axis. So if you have a function f of x, and then the new function g of x is a negative in front of f of x, that's what we call a vertical reflection of the function f of x. Sometimes it's called a reflection about or over or through the x-axis. Let me show you why. Now notice, remember f of x is a really fancy way of writing y. So you could write g of x is equal to negative y, where f of x was just y. So what happened was all your positive, or actually all your y values changed their signs. So if we look at this, notice how if you change the sign, so say all of them are positive, this is the positive sign for y. Down here is the negative signs for y. So if we go from f of x, and notice how for these, they're positive because of this function right here. They're all above the x-axis, so they're all positive y's. Now if we have a negative f of x, well, that means all of our positive y's have now become a negative y, so that throws it down here or over our x-axis. Oops. Okay, so our x-axis. So that would be a vertical reflection. Now a horizontal reflection, given a function f of x, the new function g of x is equal to f of negative x. And that's a horizontal reflection of the function f of x. And we sometimes call this a reflection about or over or through the y-axis. Now notice how you start off with a positive x. Well, now we change it to a negative x. Okay, so all of these over here on this side are your positive x values over here. This would be your negative x values. So what you're doing is when you have a horizontal reflection, you're changing every single x value you have from the original sign to the opposite sign. So the ones that were positive, well, now they're negative. The ones that were negative, well, now they're positive. Okay, so notice right here, let me get rid of this. Notice over here, from this starting point over here, these are all positive x values. And then over here, these are all our negative x values. Now, when we reflect it over or have a horizontal reflection, what we do is the ones that were positive, well, now they become negative. Okay? The ones that were negative in our original function right here, well, now they become positive. Okay, so now we have this new function right here that is reflected horizontally over this y-axis. Okay, so this one's over the x-axis, this one over here is over the y-axis. So let's look at this. If f of x is the square root of x, or let f of x be the square root of x, if g of x is the graph of f of x reflected about or over or through the x-axis, then write a formula for g of x. Okay, so we said if we're going about the x-axis, then that's going to be a vertical about the x-axis. That's a vertical reflection. So that means we need to put a negative in front of our function. Okay, so g of x would be negative square root of x. And this would be a reflection about the x-axis. So the black function is just the square root of x. Notice how it starts at 0 and it goes towards the positive x values. The blue function is negative square root of x. Now that is flipping over the x-axis, or its reflection about the x-axis. Now the purple function, that's the square root of negative x. And notice compared to the black function, it is flipping over the y-axis. So that would be a reflection about the y-axis. F of x be equal to 1 over x squared. G of x is a graph of f of x reflected about the y-axis, and write a formula for g of x. So reflected about the y-axis, back here, we said about the y-axis, horizontal reflection, and we have a negative put inside the parentheses or by x. Okay, so our x is x squared, so that means g of x is going to be 1 over this whole thing squared and negative x. Okay, now let's look at the graph of this first, and then we'll come back to this equation. Actually, we'll go ahead. What is a negative times a negative? Well, that's going to be a positive. So what we have is a negative x times a negative x because of that 2 right there. So really what we have is a positive x squared, right? So that's the exact same thing as the function that we were given. Now let's go to the graph and let's see what it looks on there. So the black function I have right here, that is just 1 over x squared. Now when I add the reflection about the y-axis, notice if I flip this function, it will be the exact same thing. So if I bring our function, notice that that's the exact same graph. So the 1 over x squared and the 1 over negative x, that whole thing squared, which turns out to be 1 over x squared like we saw in the PowerPoint, that's the exact same thing. So if I take the purple away, bring the purple back, it's the same graph. Now if I was going to reflect about the x-axis, that would be this blue function here. Notice how it's reflecting across the x-axis. Okay, and notice that would be negative 1 over x squared. Okay, let's look at a table. Here's f of x and here's g of x. And again, this should be g of x. Okay, so we're going to look at our x values, compare them. So I have a 4, and then I have a negative 4. I have a negative 2, and then I have a 2. I have a 1, and then a negative 1. Okay, now let me look at the y values real quick, see if anything's changed there. 5 and then a 5, 2 and then a 2, 0 and then a 0. Okay, so there's no change with the y's, but there is a change with the x values. All of them go from being positive to being negative. Okay, so how we would write our new function g of x would be f of, notice how all the x values went to the opposite of their sign. So negative x, and that would be our function. So let's look at this one. We're going to check our x values, and we're going to check our y values. So 4 and 4, negative 2, 1 and 1, no change. Check our y values. 5, negative 5, 2, negative 2, 0, and 0. Okay, so it looks like our y values have changed. And notice that 0 didn't change because 0 isn't technically positive or negative. It's neutral, so that wouldn't change. But the other two went from a positive to a negative. So what we have here is g of x is equal to negative f of x, because all of our y values change. And remember, f of x is just a really fancy way of writing y. Okay, so let's look at this. The graph below is a transformation of x cubed. We would already know that because we know the basic shape of x cubed, or we should. Write the correct equation for the transformation. Okay, so the graph you see there is a transformation. If we looked at the original graph, which would be, let's see, somewhere back here. There it is right there. Okay, notice it's going, it's on the, looks like it's opposite from what we have. Let's see. Let me go back. Looks like it's doing this number. Okay, so about that right there. So the gray function there, that is x cubed. We're trying to figure out, well, what happened, or what do we do to the x cubed to make it the transformation that we see on the graph, the black graph, or the black function that we see on the graph. Looks like if I flip this across the y-axis, then it will give me the transformation. So if I'm flipping about the y-axis, okay, so about the y-axis, move all this, then what I need to do is have a negative by the x value. So what I need to do is g of x would be negative x, this whole thing, cubed. Okay, now a negative times a negative times a negative. That would still be a negative, so this is negative x cubed. Notice that is placing a negative right before the function, which is the same thing as, go back here, that's the same thing as a vertical reflection, like we have right here, placing a negative right in front of it. So what we could have done is either one, actually. We could have taken this function here, the original one, the gray one here, and we could have gone about the x-axis. Notice if I flip it across the x-axis, it also would bring us to that transformation. So let's see that on the graph over here. Notice the black version, or the black function, is the original x cube. So when we flip it across, looks like the y-axis here, so that's the transformation that was given to us. It looks like it's flipped across the y-axis. But notice, if I flip it across, get rid of that, if I flip it across the x-axis,